Respected dignitaries, participants from various institutes, and my dear colleagues, a very warm good morning to one and all. I, S. Rangeshwaramma, Assistant Professor, Department of EC, delighted to welcome you all on behalf of Gates Institute of Technology for the 5-day faculty development program on design and innovations on wireless communication with advanced technology, organized by Department of EC, Gates Institute of Technology, Gutti. Learning gives creativity. Creativity leads to thinking. Thinking leads to knowledge. Knowledge makes you great. It's my pleasure to invite the convener to this faculty development program and head of the department, Dr. Archak Praveen sir, to address the gathering.
Very good morning, one and all. Myself, Dr. Archak Praveen Kumar, convener for the FDP, organizing today. Distinguished keynote speakers from premier institutions, delegates, colleagues, ladies and gentlemen, good morning to everyone. On behalf of Electronics and Communication Engineering Department, Gates Institute of Technology, I am delighted to welcome you this morning to a 5-day faculty development program on design and innovation on wireless communications with advanced technology. Thank you for being here on this virtual platform and to bring your energy, ideas and expertise, and we have participants 200 plus from the different parts of the country. I would like to welcome and give special thanks to our Managing Director, Sri G. Raghunath Reddy Garu, our correspondent Madam V.K. Padmathamma Garu, our Director Smith V.K. Srivani Garu, and our beloved Principal Dr. Syed Surya Garu for their suggestions and support. My team who have been supported throughout this right from its inception, and I welcome and thank today's chief guest, Dr. Madam, Associate Professor and Head of the Department of ECE, JNTUA College of Engineering, Anantapur, for giving her valuable time for us in spite of her busy schedule, and also I welcome all the eminent speakers. Gates Institute of Technology was established in 2001, is affiliated to JNTUA and accredited by NAC and NBA. The institution also got autonomous status and recognition of 2F and 12B from UGC institution, is certified by ISO. The focus is to inculcate continuous learning habit with positive attitude and ethically sound values within the faculty and students. The institution has always envisioned instilling life skills among the students through their participation in various curricular, extracurricular, and co-curricular activities. Progressive thinking of our late correspondent, Sri V.K. Sudhir Reddy Garu, has made Gates stand tall as one of the very first and few educational institutions to completely run on solar power. Institution is headed by Dynamic Managing Director Sri G. Raghunath Reddy Garu, Correspondent Smith V.K. Padmathamma Garu, who is the heart and soul of our institution, and Director Smith V.K. Srivani Garu, who is giving a new direction to the institute. Department of Electronics and Communication Engineering has an intake of 180 for UG. The department has well qualified, dedicated and experienced faculty and committed supporting staff. The institute allows students to further enhance, update and fine-tune much needed specific domain skills and soft skills through various training programs and workshops at different levels. In order to facilitate this, the institute signed an MOU with Village Energy Australia, APSSDC, IUCEE, Florida Atlanta University, USA. Once again, I thank all the eminent speakers who are presenting here. Thank you.
Thank you, sir. Thank you very much for giving your valuable insight on FDP. Now, I would like to request the co-convener, Dr. S. Kannappan, sir, to give a brief introduction about the chief guest of the today's program.
A very good morning to all of you. Honorable Chief Guest, distinguished speakers, esteemed colleagues, and all participants, welcome to the 5-day online faculty development program on design and innovation on wireless communication with advanced technology. As the co-convener, I am delighted to welcome the Chief Guest, Dr. G. Mamatha Madam. She is an accomplished academician and researcher, currently serving as an associate professor and HOD of Electronics and Communication Engineering at Jawaharlal Nehru Technological University College of Engineering, Anantapur. Holding a PhD in Electronics and Communication Engineering, she has an extensive academic experience of 18 years, specializing in embedded and VLSI systems. She has actively engaged in both teaching, research, and demonstrating her expertise in the field. Her research projects, including DST, Science and Engineering Research Board SERB funded project on implementation of IoT security solutions for healthcare monitoring systems, showcase her commitment to advancing technology for societal benefit. As the principal investigator of this project, she secured a grant of rupees 21,25,520 rupees, highlighting her capabilities in project management. She has guided PhD students and contributed significantly to the academic community with numerous publications in reputed journals and conferences. Her research interests span various areas such as image fusion algorithms, VLSI, and IoT technologies. As an IEEE senior member, she actively contributes to the professional community, serving in leadership roles, including Secretary cum Treasurer for IEEE ATPSS ECM and Chair of Industry Application Society Student Branch Chapter. Recognized for her exceptional contributions, she has received prestigious awards, including the International Outstanding Research Award and the Award of Asia's Science, Technology and Research by Astra. Her dedication to education is evident through her roles as NSS coordinator, skill development and incubation center coordinator, and IEEE student branch counselor. She is not only a distinguished researcher, but also an inspiring personality, contributing significantly to the academic and professional development of students and colleagues. Thank you, ma'am. Thank you for accepting our invitation. We are fortunate for being your presence in our. Thank you.
Thank you, Kannappa, for a nice introduction.
Thank you, sir, for your enlightening us with your inspirational words. We will try to make the best use of the program to improve our skills. And I thank very much for your inspiring words. We are very thankful that you have accepted our request and graced the occasion, in spite of your busy schedule. Thank you very much. Now I would like to invite Honorable Correspondent Srimati V.K. Padmavathamma Garu to speak a few words.
Hello, ma'am. How are you?
Fine, ma. Happy to see you.
Yeah.
Good morning.
and welcome to the national level 5-day program. It is very pleasure to see you as a guest lecturer here. Very thanks, Ma. Many thanks. Use in a proper way, and share of the knowledge is the most important in our building the career. Thank you, Ma.
Thank you, ma'am.
Thank you, ma'am, for your inspiring words. Now, I would like to request our beloved Principal Madam, Dr. Syed Suraya Madam, please address the gathering.
Thank you, Rangeshwari Madam. Good morning, everyone. And I have the great pleasure of extending a warm welcome to each and every one of you for our faculty development program on design and innovation on wireless communication with advanced technology. First of all, I'd like to congratulate the Department of Electronics and Communication who has come forward to organize this faculty development program. I would like to express my gratitude to Dr. G. Mamatha Madam, Head of the Department, ECE, JNTU Anantapur, and Dr. K. Krishna Nayak Sir. Welcome on board, both of you, Madam and Sir, and all other speakers of this FDP who have accepted to deliver lectures on the related topics. So I would like to welcome everyone on board for this online 5-day faculty development program. Throughout this program, you'll have the opportunity to engage with distinguished speakers, collaborate with your peers to exchange valuable insights and experiences. I encourage you to actively participate, ask questions, and share your perspectives. The success of this program lies not only in the content delivered, but also in the vibrant exchange of ideas among our faculty members. Once again, welcome to the Faculty Development Program. Thank you. Thank you for giving me this opportunity. Thank you.
Thank you.
Thank you, ma'am, for your inspiring and motivational words. Now, I request Day-1 speaker, Dr. G. Mamatha Madam, to take over the today's session on the topic VLSI for wireless communication applications. Ma'am, please take over the session, ma'am.
Yeah, thank you. Is it visible to all of you?
Yes, ma'am.
Okay. So you all introduced me, and then Kanapa has given like a brief introduction, nice introduction about me. So I need not introduce myself again. So actually directly we'll enter into this one, your topic. Like innovations, and then basically wireless communication. In that wireless communication, what advanced technologies are introduced, and with the era of electronic technology, so what changes happen with the wireless communication? We'll have a complete a brief in this session. So first one is agenda anyway. First thing I just want to know, like how that communication happened in our ancestors' time, and now how that this one communication is happening. If you see this diagram, so you can observe that earlier, like in ancestors' time, so that communication is happening with the fog. so that the fog, wherever we are and where that information we need to pass to that other group of people, so they just have to create a fog, so that will travel, and that gives that information other group of people are somewhere. So with that older communication now again replaced with the technology. The technology you can observe here. There's a diagram. So that technology, that fog has replaced with the signal. So fog is replaced with the signal, right? So that signal will travel in a channel. So that will take the information, and that information will be given to the destination or else the receiver. So communication, any communication, generally any communication is nothing but the information has to transfer from one source to the destination, right? So one one part to next part. So here that source we call it as a transmitter, and the destination we call it as a receiver, right? So that the transmitter will send the information, that information will pass through the channel, and that will be given to the receiver. So that information from sender to receiver, so that can be carried through the channel. The channel may be wired channel and or maybe a wireless channel. And so in our earlier technologies are preferred to use wired communication. So wired communication is nothing but all the way like from transmitter to the receiver. We have to provide a wide connection. Through that wires, the information will be passed, and then at the destination, that information will be received. So that is a wide communication. And again, later, that wide communication, there are many drawbacks. Why? Because with the devices or the gadgets, what we are using in our current scenario, if that is a wide communication is there, so the complete world will be have with the wires only. And so there will be no space for other things to do anything. And so complete world will be occupied with the wires, because that many gadgets, that many devices we are using. So that has to replace with some other thing, that is a wireless communication. And then wireless communication is nothing but there will be no wire. There will be no wire from source to the destination. That source and the destination may be again that source and destination, if only one device is acting as a transmitter and other device is acting as a receiver, then we may take it as a half duplex. Half duplex is nothing but all the time that will only send the information and other will be the receive the information. But full duplex we need to have. Sometimes receiver has to behave like a sender, and the sender has to behave like a receiver. So in that way, both the sender and the receiver will change according to that information and according to that application. So here, the data or else maybe the information, it may be any information, so that has to transfer from one terminal to other terminal through that media. So that media is a wireless media. We say like basic one is why wireless we are going is nothing but to reduce the complexity, to reduce a complete or else a full of wires all over the globe. So we just entered into the wireless communication. So that wireless communication, again, there are many technologies have intervened. So with that, there are many things or came into that picture like bandwidth and then the speed, one technology to the other technology, or else one generation to the other generation. So everything has changed, and through that changes, a lot of things have happened. So in that one, basically we should know why wireless communication. So why wireless communication is nothing but freedom for from wires. Also cost will be minimized, and also the complexity also minimized. So installing the voice and all, we can reduce the cost, and then physical connection setup also we can reduce. So with the help of Bluetooth and Wi-Fi, so we can send that information or the message from one source to several, resulting for the help with higher technologies. And also based advantage the Wi-Fi. So we globally we can cover everything with the help of Wi-Fi technology. So the cost we can reduce very with the help of the technology. Every time we can want to with the help of Wi-Fi and Bluetooth technology. Quality is also a problem. So connectivity is also a problem. There are many challenges need to recover when we use Wi-Fi technology or else with the wireless technologies, and also hardware. So here the advanced technologies, you just have, my topic is completely on VLSI. So that the VLSI is nothing but the hardware. So that is those are the chips. So chips we need to introduce. So those chips has to compatible with the whatever technologies are coming forward. So like from the first generation to the fifth generation. So we are now we are using currently in India. Only for mobile phones, we are using the fifth generation technology. So that the fifth generation technology for all agents to do that, hardware also has to design, and hardware has to compact or else to integrate the technologies of Wi-Fi and also the fifth generation. So that the hardware or else the chips, VLSI chips, we need to generate. So those chips will be present in your mobile phones to support fifth generation speed and bandwidth and also the applications, whatever, right? So everything is possible with the hardware. So that hardware is nothing but the VLSI chips. So those VLSI chips are to be designed to give whatever facilities are there in fifth generation or it's the wireless communication. So here we'll just concentrate or else we just go through that for one generation to the fifth generation, what changes happened, and then how can those advantages from one generation to other generations be accomplished. So here the first generation is introduced in the 1980s. Before going to that first generation, we should know even at the zero generation. So zeroth generation is nothing but there are also phones are there. Phones are there that is completely wired connection. So there only by pressing the button and the tower, there will be one transmitter will be there. That transmitter on the tower, highest building or else highest top of the tower, the transmitter will send that information, and that person wherever they are sitting, so they will have that hardware, and by pressing that button, they will receive that information. They'll receive that information, right? So that is the zeroth generation. But in the first generation, 1980s, so that first mobile phone introduced. In the first generation, first mobile phone. So that mobile phone is limited to only voice calls, only voice communication, right? So whatever we talk, only that information will be transferred to the destination, other side. So that there are many limitations of first generation devices, that is a phone, voice quality is very poor, and then only voice calls, only whatever we talk, that only can be transferred from one phone to other phone, and also the size of the phone is very high. It is very difficult to carry, but our requirement is more to carry that device. So people are carrying those devices in the year 1980s. So, hello, yeah. Slides are not changing. Okay, 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 I'll do. Now it's coming. First generation, second generation. Oh, okay, okay. So first generation. So like I said, in 1980s, that is introduced in the country Tokyo initially. So and again, all over Japan, just have used for generation mobile phones. So later, and again here, only the drawback why quality of voice is very poor is because of analog signal. So analog modulation they have used. So because of analog voice, so that the quality of voice signal is very poor. And then in the 1990s, second generation mobile phones have discovered. So those second generation mobile phones, the advantages when compared to first generation, whatever are not there, applications are not in first generation is nothing but them. Here, they just have introduced SMS. So even you can send text messages also, not only the voice information. So you can send even text messages. So the text message is nothing but short messaging services. So in the second generation, they just have introduced short messaging services and also MMS, multimedia services. So that multimedia services are also limited. So those are just wait. Sir, వస్తున్నారా? Sir. Okay, sir. I'll be ready. Yeah. Basha. Basha.
Okay, madam.
Yeah, Vijay sir is coming.
Okay, madam.
Yeah, you please carry on. I'll join later, right?
Okay, sure, madam. Thank you, madam.
Sorry for the interruption.
Okay, madam. We will continue, madam.
Yeah, please.
Okay, madam. Thank you very much, madam. Thank you very much.
Sir, Manan sir.
So, dear all participants, due to some emergency meeting for Mamatha madam, so now we'll rejoin within 5 to 10 minutes. So, Manan sir, Dr. B. Manan sir will take over the session. Thank you very much.
Hello, good morning, colleagues. Can you hear me?
Yes, sir. Your voice is audible, sir.
Okay. So I will
Thank you
start with the
very much,
slide
sir, for accepting our request and joining for the session, sir.
Yeah. Can I open the slide and
Yes, sir. Yes, sir.
how to project my slide from the cell phone only? Can I project it or I have to come on this one? Only
Sir,
from
in the mobile, you will be having a share option, sir. From there, you can project, sir.
mobile. Can I share?
Yes, sir. Yes.
Make your video full screen. Yeah. Now, how to share? I have not shared so far. Share screen. Yeah. Now
Yes,
it
sir.
is showing the
Yes, sir. It is visible, sir.
VLSI for wireless communication that now the screen is moving. Is it
Yes,
okay?
sir. Yes. Yes, sir. Okay, sir. Okay, sir.
You are able to see?
Yes, sir.
1 minute. I have to connect with this one. Yeah, it is connected, but it's not coming. There's no problem with my speech, no?
No issue, sir. We are audible, sir.
Okay. So, Dr. Mamatha Madam told about challenges and how the communication developed over a period of time, starting from 1G to what we are experiencing now in 2020s about 5G. So 1G refers to first generation and its speed was only up to, you are able to see the 1G slide?
Yes, sir. Yes, sir.
So its speed was up to 2.4 kilobits per second. We have seen the whole progression of events in this technology development or technology evolution. I have been witness to this because we started with 1G in 90s when the initial mobile phones came. The speed was only up to 2.4 kbps and it allows only one voice call at a time, and in one country we don't have any choice of sending SMS or even this videos and any kind of files which we are able to send now. For example, this PPTs and doc files, everything was possible for the past few years. So the 1G network used totally an analog signal. There is nothing but, I'm sorry, this one is going off. Okay. Okay. 1G used analog signal is nothing but a telephone connection, and which we had one extended wireless link from the landline telephone. Then it was the high tech those days. Then we have changed over to all these disadvantages you all know: poor voice quality and large phone size, no security, limited capacity, etc. Then 2G technology came as a very big revolution for us to understand and use the mobile phones over a large amount of bits can be transferred. Here comes that SMS and other facilities started coming. Then 2G networks were using totally a digital setup or digital signal. The data speeds were still up to 64 kilobits per second. Are you with me? Are you able to hear? Hello?
So it is clear, sir.
Clear? Okay.
Yes, sir.
So text messages started, and then we graduated to multimedia messages. Multimedia messages means that a limited number of other media, that is a small slide or doc file or something can be sent with more bits. That is, SMS had a limitation of only sending text, but here we had some facility to send even video clippings of a very short duration. So then the capacity increase. This, if you see the progression of technology, what we are aiming is to send more and more bits, the limited bandwidth. Bandwidth is only limited to 4 kilohertz in voice channels. And we are having a number of voice channels tagged together. But within the same 4 kilohertz voice channel, roughly about 4 kilohertz voice channel, it's actually speaking the voice bandwidth was 300 hertz to 3.4 kilohertz. That was the original voice channel bandwidth. So within this band, what maximum number of bits can be transmitted? That is a challenge. So we are trying to compress the bits, or compression is one aspect of the idea of sending more bits. Secondly, what we want to do is to use some techniques like OFDM and various other techniques to pack more number of bits within a short bandwidth like 3 kilohertz or 4 kilohertz, what voice channels we are having. So that is the challenge. So we graduated from 2G technology to 3G technology and so on up to 4G technology, 5G technology, etc. So I know some friends who worked in 2G to 3G technologies in olden days. In C-Dot, there used to be a company called development of telematics, it was called. Telematics was the keyword. So the development of telematics was a big project during Rajiv Gandhi's time, which had some electronic exchanges to be developed within India. So they are developing electronic exchanges, and their challenge was to make 2G and 3G technology. That is, graduate from 2G to 3G technology. That time, most of the people believed and strongly believed that 3G is not possible at all. 3G can never be possible with this bandwidth and with this kind of modulation techniques. How can we get 3G technologies possible? Then it was a via media solution was the 2.5G, or the speeds which are possible with 3G we cannot achieve. So we are trying to achieve somewhere in between 2G and 3G technology. So we are trying to settle down at 2.5G. That was the key results which we developed during that time. That is in the 90s, you can say. So that was in from 90s we are trying to increase the technology, increase the bandwidth, or increase the number of bits per second within the available bandwidth. So that's how we are now going on to 4G and 5G. Then we are still in the 1G and 2G wireless systems. See, I'm going to skip these signals which have already been discussed. So like I mentioned about 2.5G technology, that is the ultimate, we thought at that time, that we cannot reach 3G. So we will settle down at 2.5G. And we will combine that with GPRS. GPRS is still a different type of technology, which we have also come across during the Reliance phones. Reliance, not this present Reliance, the earlier Reliance phones, which were available at 500 rupees a piece, and there was a lot of rush to collect those phones and then use them even among common public. It was very popular. So there, the technology was not GSM, that was called GPRS, which is a fine, far superior to GPS, which we are GSM, which we are using even now. Also, we are using GSM, but GPRS is a total different technology, and which had a lot of advantages in terms of low power requirements, and then this complication in the base stations and all were much less. So the technology combined with GPRS, we were using it in 2.5. This incidentally, this cell phone which you are seeing in the slide was my first cell phone during the 2.5G use, when 2.5G was used. Then actually the progress of human life is only possible when you go to the next stage. That means we started with 64 kbps, then we came up to 120 kbps in 2.5G, and then 3G technology refers to third generation of telecom devices which were introduced in the year 2000, early 2000 it was introduced. Then also it was not available so easily and frequently in India. They were able to communicate at the rate of 144 kbps to 2 mbps. This is possible because of so many types of modulation techniques which were developed. Modulation techniques like OFDM. I hope everybody is familiar with OFDM. That is to pack maximum number of bits in the same bandwidth. Within 4 kilohertz bandwidth, we are trying to achieve a data and transmission of up to 2 Mbps possible. So this type of thing requires large amount of pre-modulation technique. That means before modulation, you try to combine certain things like this phase modulation techniques we are using, and then we are using total tessellation, as they call it. The dots of frequency and amplitude both are varied to get the same bits, that is a large number of bits within the space of frequency versus amplitude diagram. If you see, a lot of dots will be appearing. That is the basic idea of packing more number of bits in the available bandwidth. So that is how we are able to achieve 2 Mbps speeds for 3G. Then 3G technologies have given way to some higher level of 4G technologies. These are some advantages which we have seen nowadays, which is very easy to see the cricket matches. That when it came first time in 2001, 2002, cricket match streaming and all were there. That time it was a novelty, and everybody used to flock in to the device where 1 or 2 persons will be having this 3G technology device, and then a big group will be surrounding them to watch the cricket match through the cell phones. Now it is a very common experience for us to use cell phones for watching live cricket matches. Then we also were keeping in phase with the developments taking place in the world. So that's how we are able to catch up with 3G and 4G technologies because of the advantages of liberalization and opening the market to all the foreign players. So we are also in touch with the technologies, and we are getting all the developments immediately here. When something is happening in US and Europe, within 1 or 2 years, we are also experiencing the same technologies available here for us. And it is all due to the globalization and liberalization of policies. And all the foreign players have come, and the collaborations are taking place, and they are supplying equipment to leading players like Airtel and Jio. Now we are getting the advantages of using 5G technology. So I will skip this 5G and skip this 4G, and we are all familiar with that. We'll go to 5G straight away. So 5G technology referred to short name for 5th generation, which started in late 2010s. That is the past decade. It has been going on. Then complete wireless communication and no limitation. That means what is the ultimate aim of this development? We want to have instant communication. We cannot even miss a few milliseconds of, let us say, in 4G, we were getting the live transmission after a few milliseconds. Whereas with 5G, we can get it almost instantaneously or within a few milliseconds. That is, it used to take about 100 milliseconds, let us say, in the previous 4G technologies. And then now we are able to get within 1 or 2 milliseconds or even less than 1 millisecond. That was a requirement of a number of, for example, autonomous vehicles, tele-robotics or tele-operations, medical field. They are doing, robots are doing operations across the globe. Suppose the doctor is sitting in US and operating on a patient in India, there should not be even a millisecond delay because there is a feedback mechanism going on, and the doctor will feel the patient's reactions and patient's outcome of the operation. Immediately you should be able to see and take corrective action within 1 or 2 milliseconds. It cannot be after a few milliseconds also when the live operation is going on. So this type of robotic surgeries are possible with 5G. So we go into 5G mechanism, which will promise or which will deliver the input and output within a few milliseconds. It's also available in autonomous vehicles, where the autonomous vehicles can be controlled from a central place, or even within the same vehicle we are getting inputs, processing them, and then we are transmitting the outputs to the autonomous vehicle. That means the operation of gear and steering wheel, etc. All these things are possible only if the entire network is operating at the speed of 1 or 2 milliseconds. That is possible when the network is able to reach a speed of 1 gigabits per second. That means we are able to get 5G technology when the network is capable of transmitting up to a speed of 1 gigabits per second. Then we can see TV proceedings, and then even the cricket matches, sometimes the live operations, all these things are possible only with 5G. Faster data transmission is the basic requirement. So what are the challenges of 5G? Once you agree and accept that 5G is advantageous and we want 5G today, then what are the problems we are facing? We have to have large phone memory. We have to have large, storage space. Storage space as, the bulk storages which are supporting 5G, and reading and writing from those storage spaces also have to be fast. That means it may be transmitting and receiving from one end to other end, but if you have a buffer storage within this device, which is slow, which will take, let us say, 1 or 2 milliseconds to display, or 1 or 2 milliseconds read and write from that buffer storage, still we are handicapped. We cannot reach 5G speeds. So it is also closely linked to VLSI developments, VLSI technologies. So we have the following, stepping stone from 4G to 5G. What are things required? We are seeing speeds up to 20 Mbps in 4G, though we always promise 20 Mbps, we don't get really 20 Mbps in reality or in what is called the practical situation. We try to get 20 Mbps. The equipment is designed, but due to various problems in the network, various switching devices, and a number of bottlenecks in the network, and also reaching a place from A to B through different routes, then the speed will reduce or the throughput will reduce. Throughput is we require 20 Mbps, but still we are able to achieve 10 to 15 Mbps. We are still happy, but it will still be slow for our requirements, like robotic surgery, for example. So we require up to 1 Gbps. Then we try to upgrade the technology by means of whatever technology we have in VLSI, we have to upgrade it to reach that level of 1 Gbps. 1 Gbps requires, like I mentioned, about fast memories, fast read, fast throughput across the network, fast switches. All the entire network has to be refurbished, or it has to be upgraded to handle 5G speeds. So that is possible only when you upgrade your VLSI manufacturing techniques and VLSI, what is called VLSI devices, whatever devices we are having, they have to be upgraded to receive and transmit 5G speeds. So wireless applications use free space. These are all some basic stuff which I will again go through. So this is one of the famous how this microchip doubling takes place. Moore's law, which is a very famous one. In every VLSI book, you will find this in the introductory first chapter, how the expansion took place from 1970 to present date, about various companies, various kinds of storage devices, and also a number of transistors, basically transistors packed within a small space of in micron sizes. What is the micron size? And transistor count is now coming to 50 billion range it has come to. And a lot of leading companies like AMD, Intel, and Samsung, Silicon, what is called Apple A13 phone. You will see some of this. I don't know whether it is clearly visible or not. These are the Moore's law's, square law, as they call it, initially it said that it will square or it will double every year. The number of transistors within a square centimeter or square millimeter will double. That was so. It is actually now increasing at the rate of square. That means if it is 4 this time, next year it will be 16. That means a square law is the Moore's law, which describes the number of transistors which are increasing year by year. Our requirement is increasing and the transistor count is also increasing to reach the maximum level of between 10 billion to 50 billion transistors in 1 square centimeter we are expecting. We are talking about these days. So how to gear up the VLSI technology to reach this level of density or this level of packing of multiple transistors in one small area. So it will have its own challenges of finding associated technologies. That means we are now getting into some sub-micron level. Sub-micron we have already reached long back, but we are now getting into sub-nano level. That means once we get into nano technology, nano level particles will behave much different from micro levels. We have seen in nanotechnology areas where nanotechnology doesn't follow the same way of electron flow and electron density and connectivity and all that is different from nanotechnologies. Nanoparticles are behaving totally different manner compared to the VLSI and micro miniaturization technology, which we know in VLSI. We have to recast our theories and our devices which are required to manufacture this VLSI will be totally different now. So we are somewhat like reaching a technology which is saturating, which is actually coming to a level of point of no return. As they say that you cannot go beyond certain level. You are going to be stonewalled by the technology of handling this 10 to 50 billion transistors in 1 square centimeter. That type of technology handling by associated devices is going to be very difficult, and the theory is also going to change from micro level chip technology to nano level chip technology is going to change. But still, we are still operating in the same nanotechnology area, and we are trying to achieve whatever be the number of transistors per that square centimeter area we are trying to achieve, and then also interconnections, heat dissipations, and the speed of electron flow within that area. All these things are getting into a big challenge for VLSI designers and VLSI manufacturers who are going to make this dream of realizing 5G technologies. So we have some things like, this is a general area, general procedure about how to go about program and data working on a certain storage and then control unit. It's basic computer. If you see the computer organization, initially what we have studied in second or third year of engineering, computer organization is somewhat similar to this, which is having some storage unit, some control unit, logic and arithmetic logic unit, and input-output devices. Is nothing but the basic organization of any control system or control computer which we are trying to build in a VLSI system. So we have input unit, output unit, which will be sending program and data on one side and then getting the program or getting the output in terms of results. Results in this case will be in the form of operating some other devices, operating some, let us say, stepper motor to start with, stepper motor or some kind of, mechanical devices may be operated. Then it will go into some decision making, like autonomous vehicles will be operated and they will take some decisions. Those decisions will come out in the information or result stage. So here the results are coming out in the form of application of AI, etc. We are going to put this type of computer devices into decision making using AI and ML, which is going to be the most challenging aspect of the present generation VLSI devices. That means they have to support a large number of neural networks in learning and also taking decisions or classifying certain things and classifying certain inputs and giving outputs in the form of decisions. That means it will say go straight, go right, or take a left turn, something like that. So all these outputs will be taken for granted when you have a proper neural network operating on this one. Just a minute, I will take a 5 seconds. Okay. One minute, I am here. There's some interruption, please. Please bear with me. Another 2-3 seconds. I'll be back. Hello. Yeah. Are you getting me?
Yes, sir, your voice is clear, sir.
Sorry for the interruption. There was some. So these are all of some historical interest and some illustrative examples of how we have progressed over a period of time. In fact, when I think of this vacuum tubes, all these vacuum tubes we studied in our BE Electronics and Communication Engineering in way back in 70s, end 70s, I was studying only about these vacuum tubes. Then it became transistors at the time of leaving, and integrated circuits were just introduced. And Millman and Akias was the standard textbook those days also for VLSI was not in sight at that time. So this shows whatever progress we have gone through. They're all of historical interest, and we'll skip them. What time is the class over? Till 11 o'clock? Sorry, till 12
Sir,
o'clock?
it's up to 12:30, sir.
Oh, till 12:30?
Yes, sir.
I'm supposed to speak till 12:30, is it?
Yes, sir. Yes, sir.
Or somebody else will take over from me.
Sir, no, sir. You continue up to 12:30, sir.
Oh my God. So, okay. Anyway, yeah. So, the developments which have taken place. You people are also familiar with these floppy disks and CD-ROMs and USBs. All these things are now getting again obsolete, because now everything will be in terms of flash storage devices, which are very small in size, and then also large amount of storages are available in flash devices. So we have now gigabytes of storage in small pen drives, which are going to be, and then the next stage will be in quantum computing and quantum storage devices, which are still in the horizon. It is still just appearing on the horizon. So we will come after 5 to 10 years, we will come to that stage of, everywhere quantum computing will be there. So we have the illustration for how this entire board is shrinking. A PCB is shrinking in size over a period of time, and it is also known as standard ATX, micro ATX, mini ITX, nano ITX, and NUC Pico ITX. Pico is a 10^12 range of VLSI chips which are using. So we trying to illustrate and give an example of how the miniaturization and a large number of transistors getting packed in one small area is changing the way we use the PCBs, and then we use the devices also, or affecting our design philosophy, as well as devices which are going to be packed in such small areas. They have to be carefully studied, and we have to use certain design techniques and design principles also will be changing. And also we have some kind of associated tools and techniques which are going to be also changing. The way which we used our laptops and PCs for studying and deciding about the design, testing the design, and then putting it on stream for making the VLSI, the total thing will change. Now entire software, hardware, all the associated tools are going to be transformed into handling some 5G technologies and miniature VLSIs, and some more complicated or sophisticated VLSIs will be coming in the scene, and we are trying to gear up for handling such type of VLSI tools. Then we are trying to see how one chip can handle so many functions. For example, memory functions. Memory was supposed to be on separate chips, where we had only cache memory used to be within the processor chip, and then now the single chip computers and all the functionalities of a single chip include things like wireless transmission in Bluetooth, Wi-Fi modules which are going to directly talk to Wi-Fi transmitters and receivers. All these things are going to be built in one chip. So within the chip, it is increasing the complexity of the chip, as well as the problem of designing and also testing the chip is increasing manifold. The complications increase manifold, because we have to have all the functions built into a single chip, unlike the olden days where we had separate chips for separate functions, such as memory or wireless chip was separate, Wi-Fi chip was separate. So all these things are getting into more and more complicated for us to design VLSI chips, as well as to test them. And when the chip is built, then we have to take the chip and then put it on a test bench and then test them for all these functions. That is also increasing the level of sophistication and requirements on the test bench, which we have to design for testing each chip before sending it out of the market. So that is the final stage of testing. So before manufacturing, one level of testing takes place in the simulated atmosphere. And then we try to give the inputs and outputs and check the outputs and see whether they are working in order or not. Then we try to take the actual chip and then put it under the situations where it is going to be used, and then feed the data and then see whether the output is really working according to our requirements, according to our design or not. So all these things will take a lot of changes, or the way in which this whole VLSI design and VLSI testing is done presently is going to be changed. When you go into the 10 to 50 giga numbers of transistors, giga transistors per square centimeter or whatever. So we try to gear up ourselves to get into this technology of 5G, along with whatever we have in VLSI, and upgrading the VLSI systems, VLSI design systems and testing systems to reach that level of sophistication. In the cell phone example, you will see that cell phones are having very few chips. If you open the cell phone and see, there will be hardly some 3 or 4 chips. Right now, we are using them for various uses, something like the processor, storage, memory, and this Wi-Fi, Bluetooth. All the Bluetooth and Wi-Fi, they are already coming with built-in to these cell phones. This Qualcomm is manufacturing already with all the wireless and Bluetooth modules built into the single chip. So same way, we will require a single bus system in which a powerful set of processors will be working. There are some quad processors and 8 processors in one line or 16 processors in one line. All these things have already started coming. Then we have the entire computer is built into a single chip with sufficient amount of flash memory, and also the Ethernet and output controllers are also built into the same chip, which are trying to make use of this density of a large number of transistors and trying to use the technology of VLSI. They are going hand in hand, technology developing together with the requirements of the market. Then we are trying to make use of the available technology in VLSI and trying to use this is a typical example of a cell phone, let us say a cell phone or a network, a device connected on the network and which is transmitting and receiving through the network the required data, which is running in, let us say, 5G speeds. So for this kind of setup will be required. Then the application side, we come that it has got so many interconnecting networks which are operating within the city, within the building, and across the cities, across the continents, even across the countries, across the continents, and from flying objects to ground systems and through the satellites. All these things are possible. It's a self-explanatory kind of future scenario in which your 5G is going to be employed and utilized. There are some different types of networks where Madam was telling about wired and wireless networks, how wired and wireless networks will interoperate, how wireless networks to a next level of space communication that is going through the space and accessing the satellites which are at 36,000 kilometers height. That is, they are into the geostationary orbits where they will be stationary to an observer looking from the Earth. So these geostationary satellites are useful for relaying the communication from one place to another place seamlessly across the geography. That is 1/3 of the Earth, 1/3 of the globe can be covered by a single satellite. So 3 satellites may be only required for covering the entire globe. And between satellites also there will be communication which is not really shown in this one. Inter-satellite communication is also possible for transmitting from one part of the globe to the other part of that is the shadow region of the globe. This satellite will not be able to see more than 1/3 of the globe. Whereas we try to link satellites in space so that we can transmit from any place on Earth to any other place on Earth, even though it is not seen by the same satellite. So inter-satellite communication, all these things have to be required to work in that speed of, let us say, 5G speeds. So we are trying to build the entire network, which is seamless, transparent, and for users such as a medical doctor or a surgeon who is operating a teleoperation across the countries. So for him or her, we are providing this network so that he or she can seamlessly and transparently operate. That means they don't come across this latency or this delay earlier experienced by 5G, by 4G. Now with 5G, they are able to see online, live, instantaneous communication and then get the feedback from the other side also, other end also, without any even milliseconds delay is not tolerated or allowed in this type of operations where we are trying to apply these 5G systems. So 5G systems are now also supporting IoT, that is Internet of Things. You know that everything which is a device or which is operation, which can be like connected through IoT, and that requires some more electronics connected to that particular device. For example, street lights. So street lights can be operated using IoT, or agricultural applications such as operating some pumps, operating the machines through IoT. All these things are possible because every device which is going to be operated is connected with some extra electronics or extra VLSI chips to make it connected to internet. That means anything connected on the internet becomes IoT technology. So we require all the available equipment and available things which are going to be supported with IoT chips and IoT technology so that everything can be operated across the network. That's what is happening in some science fiction kind of situation where in future, all the vehicles, even though they are not autonomous, if they are connected to IoT, if they are connected to internet, then somebody else can take control of your car and they can drive the car across the city or across the country using this IoT device. So its IoT is come with a danger also. That is not really 100% safe because it can be broken into or it can be interfered, and then somebody can take over the control of whatever device which you are using. They can control the device independent of you. You might have designed it and you are the owner of the device, but the control of device can be with somebody else. So all these things are also byproducts, or they are all wrong things of the design, wrong side effects of the design, which we are going to face in future with IoT type of design. So the Internet of Things, where are they going to be applied? This are going to be applied in monitoring, controlling, and also taking a lot of information and data from one end to the other end. So we have this growth from 2000 to present day, in which a set of RFID tags started with, in the early 2000, we saw that RFID tags, which are going to be used in, let us say, your laptop. When the laptop is crossing the threshold of a gate of a company, then it will be entered into the central server. And so the server knows that the laptop is going out of the building. And if the laptop is coming into the building, it will be again triggering a stream of input, and then it will go into this one, and time and identification of that particular laptop will be stored in your, let us say, your server. So anybody who wants to monitor the movement of laptops in and out of that building can go to the server and take down the entire history of that laptop's movement in and out of the building. So all these things have been happening early 2000. Now we are coming to the level of, the surveillance, security, healthcare, transport, food safety, document management. All these things are coming in the Internet of Things, because we have seen we have seen in some movies also that everything, once controlled by internet, then somebody sitting in some place, some remote place, can control even traffic lights of, let us say, Chicago or New York. Some traffic lights, electricity systems, electricity switching on and off, all these things can be controlled sitting at one place. Only thing is you should have proper password, and then the way the network is working and how they, how to access them by using certain amount of, stealth techniques, how to use password, how to break into the system. And you can break into any system because everything is now paperless records, and everywhere the files are stored in computers, and also they are taking decisions through the computers. They are conveying the decisions, let us say taking off an ICBM or firing a rocket or firing a missile can be controlled through the network. So if you break into that network, then you can also control the missile or ICBM or any other, good or bad things can be controlled. Both can be controlled. That is why this 5G has come handy for tele operations and telepresence. That means you want to monitor and control distant objects without delay. Without delay means within a few milliseconds. It was happening in 4G. Even if I can do it in 1 or 2 milliseconds or within 1 millisecond, let us say in terms of microseconds, if I can achieve the same control and operation, that's what I am looking for in 5G technologies and using IoT technologies. So everywhere bottlenecks are there. Everywhere there will be switches. Everywhere there will be alternate paths, congestion of network. Network is not enough to handle the bandwidth because a large number of people are operating the network at the same time. Then we have to find alternate routes and we have to go to some other form of networks like optical and satellite communication. Then we have to do from wireless to wire. Sometimes even sometimes the gigahertz range will change. That is transmission and receiving network. That is we have seen in the previous slide where we have come across all kinds of multiple operations in the network. That means they are having some old networks still. Some legacy networks are there, which are using some 80s, 90s technologies. And they will be having switches. They will be very slow in reaction. Slow reactions will be there. Then we try to get into those networks and get out of them at this speed, which is going to be a problem. It is not an ideal situation everywhere. It is not, see, your operating mechanism or your local device may be very fast, but if it has to convert all the signals and then send them across the globe or across the country to another country, then there are a number of bottlenecks and there are going to be difficulties faced to achieve this type of speed, whatever speed we are trying to achieve. In terms of 1 or 2 milliseconds, if I have to achieve, then it is going to take a long time to achieve that speed. That means all the network refurbing or upgradation of networks and the modern equipment or VLSI systems have to be replaced everywhere. Then every device has to be connected to IoT. All these things come as a challenge. So we have to see how much we can achieve with the available networks and available devices. Then on the one side, we'll keep on developing VLSI techniques for making the devices smart with all the subsystems built into one single chip. Or a lot of messages, a lot of inputs are taken, like in neural networks and machine learning. What we are expecting is that some millions of inputs will be given to the network. That means a million samples of human beings as seen on a video. Let us say in CCTV video, we are seeing one human being, and there will be a large number of such samples will be given to the neural network for it to learn and identify human beings in any form. In future videos, wherever videos are coming, they will try to isolate the human beings and put a mark around them or put a small box around them, confining them and identifying or labeling them as human beings. That is our aim. So for that, whatever available human being images in a street scene, let us say, in an open air outside scene, wherever human beings are available, they have to be labeled and given to the network first, to the neural network. Then it will train itself. That automatic training is the only advantage and then the attractive feature of the neural network, which will train itself to identify human being anytime, anywhere, in any video clipping which you present in future. It will identify the human being and say this is human being, and it is come to the second level of identifying the clothes the human being is wearing. It's a male or female. What is height, average height, or is it a tall human being? Like that, you will try to classify the image or human being into different classes like male, female, baby, child, or is it an animal, what animal it is, and how fast the animal can run. And all the characteristics will be tagged, like the Terminator movie, if you see. By looking at the object or image, he is classifying that this is an image, this is a car, this is a human being with blonde hair and gray eyes and things like that. So another example is we have system on a chip where you can have a controller and it will have some sensors interacting with the controller, and the controller is getting inputs from the typically a medical devices system. That is, this system is actually doing a medical test or a blood test, and ECG is electrocardiograph, memory graph sensor. That is, brain signals will be sensed, and then electrocardiograph is heart signals will be sensed. Blood glucose is monitored, pulse is taken, and then heartbeat is monitored. So all these things are put into a single chip, and then this chip is going to be a part of your, let us say, watch. Right now, watches are having things like even the SiO2, that is saturation of oxygen in your blood. It is measuring. Only BP measurement is not available. Otherwise, the heartbeat and saturation of oxygen is also measurable using the new watches which are coming in the market. So a glucose sensor is actually now invasive. Now non-invasive glucose sensors are also coming. They are just from the surface level. Can they measure the glucose? It's still research is going on, and a few systems are introduced in the market. I don't know about the efficacy or the advantage. I mean, the accuracy of these systems. But it's not going to be far off in future that all these things are available and will be used in a day-to-day requirement for monitoring yourself. Everything you can monitor yourself, and then you can also get your diagnostics done locally or within the house to some extent, and then call the doctor when something goes seriously wrong. Then we have all the problems of security, which we have seen earlier, that security and threats are going to be handled in the sense that the DDoS attack, things like, you have seen that some other database is compromised, and things like, your personal details from a credit card company can be leaked online. And then people like those who are working just to defraud through the cyber techniques. That means people are talking to you and then asking for a PIN is an olden days concept. But now they need not ask your PIN once they get into your cell phone, and they can get any information out of the cell phone, of your cell phone, including your passwords and all the mails you are receiving, and what techniques, what are the discussions going on in WhatsApp. All these things can be monitored, and then your profile can be easily understood by the person who is going to take advantage of in a future scenario without even knowing your knowledge. That means snooping and getting all the information from the cell phone once they are able to break into the cell phone. So all these things are possible with some security threats, and how to overcome the security threat is another problem of computer security, which is also a challenge for people who are working in this line, that ethical hackers trying to avoid people from hacking into big computers. For example, in some time ago, there was a problem of TRDO sites being hacked by some outside agencies or outside the country. From there, they are trying to clutter the scenes, clutter the front page of some of the sensitive sites of government of India. So how to avoid such attacks? These things are also going to be a part of your challenge of, while building the systems, you have to build countermeasures and countermeasures, how to avoid things being hacked and things being stolen from you. And another important thing is about the battlefield scenario, where defense services are requiring a number of interconnections. Drone-based attacks are coming. Now a lot of drone-based guns and bombs are coming. They're going to shoot point blank and bring the drones and then fly them interactively, remotely, autonomously, and then they can access the enemy without actual person-to-person combat. We can avoid that person-to-person combat, and then we can send the autonomous vehicles like drones and helicopters who are autonomously. That means they are able to fly on their own, dead reckoning, or they can be flown from a distance. from nowadays we are seeing that Middle East drones are operated from US itself, US bases. And there are pilots operating US drones from 5,000, 6,000 miles away in Europe or in US, and they are able to pinpoint the targets and attack them in Middle East somewhere. So this type of useful applications are there. They are trying to be useful for us if you are doing it, and if it is done by enemy agencies, then we are going to take some counter actions or countermeasures for avoiding such damages to our forces and our installations, and sensitive places should be protected properly. So these things are coming as a challenge in large quantities, and we have to design such systems based on this type of threats and problems which are going to face in future. So I think, let me check. How much time I have? Okay, few slides are there.
Sir, up to 12:20, you please continue, sir. We will have a query session at 12:20, sir.
Okay. So instead of actually going into the VLSI design techniques, what we are seeing is this is an introductory lecture. So we are building up the environment for understanding the VLSI design. That is going to come separately or subsequently. Actual VLSI design will come, but we are trying to understand the requirements. For example, this is one requirement where you have to interact with a large number of devices, large number of systems, static and moving systems, mobile systems, and those who are already in orbit like satellites, and those who are already being used as some backbone systems like optical communication systems we are using. All these things have to be interoperate. And also they have to provide 5G technologies or 5G speeds, which is actually a big trade-off. You cannot expect 5G speed from one continent to another continent or one country to another country when it has to go through a number of heterogeneous systems. That means they are not uniform. They are not designed for the same speed. They are designed for 2G and 3G speeds. And sometimes they may be even slowed down because of the volume of data. Quantity of data is too much and volume of data is too much. So there will be bottlenecks. There will be some problems experienced on the way of sending packets and receiving packets. We are still sending packets and receiving packets. So 5G is possible only from point to point. Exactly the same VLSI type of systems which you are using from one end to another end, and also a very high-speed link, non-stop high-speed link without switches and without routing, without any this one from one end to another end, dedicated lines if we are operating, and we are using the same type of equipment on both sides, then it is possible to use 5G, possible to achieve 5G speeds. Otherwise, if you are using this kind of heterogeneous network, and then we have to compromise. We have to be in a suboptimal solution where whatever best speed we are getting, we have to be satisfied with that. So this is this limiting resource. I mean, the resources which are already available to us, which are not really of that speed, we have to upgrade all of them. You see, upgrading all of them all over the world is impossible. It will be done in stages. It is depending upon the government policies, depending upon the company policies. But it is possible only with company A having headquarters at US or in Bangalore, and that company is having a number of subsidiaries or their branches all over the world, let us say. And if they want to provide 5G communication within the organization seamlessly, that means like your intranet, you can connect everything in intranet. Then there are dedicated networks, dedicated systems, dedicated switches, and all the links are dedicated, and optical communication is there, which will go in some gigabits per second. Then if your local cell phone has to operate at 1 gigabits per second, you require multiple times, some 5 or 6 times more speed in the interconnecting networks, for example, optical networks or satellite network, they should be able to operate in 5 or 6 gigabits per second. Are we geared up for that? Are we having such equipment that the company can provide? Big company, for example, in hundreds of billions of dollars, they are spending, their income is in terms of $100 billion, let us say. They can spend $1 or $2 billion and then upgrade all these systems so that within the company and within the network, they can achieve the speed. But otherwise, if you look at it dispassionately, I feel that it is a long way to go and we have to go in steps. Step-by-step solution is possible. And we have to see how to achieve this 5G in terms of available technology and stepping stone to the next level in small steps. We have to take small steps to upgrade each and every system, then try to get these things to that speed. That is what my take at the end. When you are thinking about looking into future and looking into the subsequent speakers' presentations of how VLSI is going to work. So this is only a effort building or environment in which the 5G is going to be made available. Those problems and bottlenecks have to be understood before going into the VLSI design stage and testing stages. So these are the two important diagrams which I am going to show again and introduce these problems of these networks. This is one, and the other one is about Internet of Things, where we are growing in Internet of Things, and then there are some statistics says that it is already some 2 to 3 billion devices have been already connected, and then they are going to connect within the next 1 or 2 years. The number of devices going to be at the order of 5 billion devices connected on the internet. So naturally, this will lead to so much of data explosion. Every device wants to send and receive data. Enormous amount of data will be resulting in places like networks, switches, and routers. There they have to handle so much of data, and they have to delay the data for, queuing will be there, and then some data will be rerouted. All these things will take place. So we cannot expect 1 Gbps. That is the ultimate, result. That means you should be happy to get at substandard speeds or sub speeds of 1 Gbps. What will be the sub speed? Something like, if I am getting 400 to 500 Mbps, I should be happy. And with that also, you are able to achieve the requirements of 5G. Whatever we have planned for 5G, we are able to achieve. Like robotic surgeries, for example, we can operate robotics and we can operate autonomous cars. All these things are possible only with some kind of substandard to 1 Gbps. 1 Gbps is a peak. You can never achieve that. That is my take. And as an introduction to this emerging topic, there are a number of problems, bottlenecks involved, and then we have to go cautiously, and then everybody has to gear up for achieving this speed, right from the designers, testers, and then all those designers of VLSI as well as the designers of 5G networks. They have to, I believe it is working in places like Japan. 5G is already in operation. Even here also, 5G is being offered on a trial basis by Jio. I am looking at my cell phone and seeing that 5G is shown on the top of this one, but it's hardly any, that speed wise, it is not 5G. I can measure it and see I'm getting only about 10 to even less than 100 Mbps, not even 100 Mbps. So we are far away from achieving the 1 Gbps design of 5G, but we are there. Step by step we'll reach there. With that, I will close this topic. If there are some questions, please go ahead and ask them. I'm ready for answering some questions. Okay?
Okay, sir. So I request participants, if you have any queries, please post the question in the chat box.
As usual, no questions.
So we will wait for 2 minutes, sir.
Okay.
I will read out the question for you, sir.
Yes, yes.
Sir, we have a question here, sir.
Yeah.
What is 5G related applications to tri-CMOS technology?
Not able to understand.
What is
What is
5G related applications
yeah
to tri-CMOS technology?
trisema? What is the spelling? I'm not able to decode this word
Tri-CMOS,
called
sir. TRI?
CMOS.
Yes, sir.
That is complementary metal oxide
Yes, sir.
semiconductor. Is that the
Yes,
one?
sir. Yes, sir.
So frankly, I have not studied that part. I don't know about how tri-CMOS, TRI tri.
Yes, sir. TRI try.
Oh, no idea.
So we have
No
another
idea.
question here, sir. What is the
Yeah.
speed in 5G?
Yeah, that's what I mentioned. No, up to 1 Gbps is the dream. That is the requirement, achievement. We are going to see 1 Gbps speeds in 5G. That is the ultimate. But you will never achieve that. You will be having some sub speeds of 1 GB. Even if you achieve 500 Mbps, that too in dedicated exclusive networks, we will be able to achieve half of that speed or maybe 60% of that speed. We should be happy.
I request participants, if any queries are there, please post in the chat box.
You are able to see a slide on my system, from my cell phone. It's known as Anant architecture.
Yes, sir. Anant architecture is visible to us, sir.
Yeah, that must be the project of Dr. Mamta, which is granted by the government, and then she is doing this project. But she will be the best person to explain in much more detail about it. But whatever I have understood, I was trying to decode and understand and try to explain. But actual proponent or the user of the system or the designer of the system should be able to give a better treatment to this subject, a particular project which they are.
So we have another question
They
here,
have been
sir.
funded. Yeah.
So we have another question here. Is FPGA based wireless communication is possible?
Yeah. FPGA is one of the devices which can be used to achieve the requirements of this. What is called this application? If in an application you can have system on a chip, you can have FPGA. All are possible. See, it is programming you have to do on FPGA. You have to select the gates and then interconnect them. All these things will slow down a bit, but it is possible. It may not be as good as system on a chip kind of design. FPGA is also one of the alternatives, or it can be a cheaper design. It is a general purpose device. FPGA general purpose. You have to take it and then fuse them into our requirement and try to make it work for our requirement. So in that sense, you'll be spending a lot of time and effort in making it work, and also it will be slower in speed.
Sir, okay, sir. Now we will give the session for vote of thanks to Ms. G. Reshma, ma'am.
Okay.
Good afternoon to all. I, G. Reshma, Assistant Professor, Department of ECE. On behalf of Organizing Committee, I would like to express my heartfelt vote of thanks to all the esteemed faculty members who participated in this enlightening FDP. Next, I would like to apologize any difficulties or discomfort that you may have experienced during this FDP program, as Dr. G. Mamatha Madam has an emergency meeting with Vice Chancellor in JNTUA, so we deeply regret for this. So a special mention of thanks to Dr. B. Manan sir, Professor IIT, for immediately accepting our request and continued the session without any inconvenience. Next, I would like to very special thank for the speakers, Dr. Sanyog Rawat, Dr. Krishna Nayak, Dr. Prakash Kodali sir, for your presence. Last but not least, we extend our deepest appreciation to all those who attended this program, because your feedback is very valuable to us. We hope that you have gained valuable insights and skills that will greatly enhance your teaching methodologies. So feedback link is shared in WhatsApp group and also in chat box. Thank you one and all.
Hello. I don't know how to stop it.
Dear participants, a very thank you to all. Tomorrow we will continue our session at 10:30 a.m. Thank you for your participation. Kindly, the feedback link is shared in the chat box and WhatsApp group. Thank you. Thank you very much.